Welcome, brothers and colleagues, to this explainer. I'm here to walk you through a complete masterclass on softener resin regeneration using NaCl. This is specifically tailored for UPW and industrial water treatment. If you're out there operating or installing these pure water filtration systems, you already know that this is a fundamental, yet absolutely crucial skill for maintaining water quality and protecting all your downstream equipment. So, let's get right into it.
All right, let's take a quick look at our agenda for today. We're going to start with system principles, move right into the signs of failure and common mistakes, walk through the step-by-step regeneration process, and finish up with some non-negotiable safety rules and takeaways.
Section 1. System and Regeneration Principles. Okay, before you and I even think about touching a valve on the plant floor, we really need to establish the precise anatomy of our softener column. It's the absolute foundation of everything we do here. Your strong acid cation, or SAC resin, is basically made up of these tiny golden brown beads, usually 0.3 to 1.2 millimeters in size. They actively trade their sodium ions to capture the calcium and magnesium in your water. It's literally a chemical trade-off. But as you know, eventually those exchange sites become completely saturated, and the column just loses its ability to soften the water.
So when that saturation happens, we have to regenerate, and this is where the Venturi adductor comes in. It brilliantly uses a vacuum to pull our 28% saturated salt brine and dilutes it down perfectly to 10% right before it hits the column. Whether your specific system design is co-current or countercurrent, it doesn't matter. That 10% concentration is the exact sweet spot we need to reverse the chemical reaction.
Moving on to Section 2, Regeneration Signs and Mistakes.
Picture this. You're looking at your SCADA screen and you're watching your differential pressure. If that pressure jumps 15 psi above your baseline, man, that is a massive red flag. It's basically your bed begging for attention, signaling that the resin is either compressing or getting clogged up with suspended solids. Seriously, do not ignore a pressure drop like that.
Actually, there are 4 specific triggers that should tell you, hey, it's time to regenerate. You absolutely must initiate regeneration if you see any of these. First, the big one. If your output hardness creeps over 1 milligram per liter of calcium carbonate, or whatever your internal spec is. Second, when your water meter counts down and hits its design capacity limit. Third is that 15 psi differential pressure increase we just talked about. And fourth, if you notice a significant, unexpected drop in water flow even though your pumps are running perfectly fine. Listen, brothers, I've been around the block, and I see these same 5 mistakes absolutely destroying resins constantly. 1. Using cheap salt with high impurities. 2. Letting the tank go completely empty. 3. The infamous salt bridge. It looks full from the top, right? But underneath that hard crust, it's completely hollow, entirely starving your system of brine. 4. Setting the wrong timing on your valves. And 5. Rushing the fast rinse. These rookie mistakes will completely tank your resin's lifespan, drive up your operating costs, and let's be honest, nobody wants to spend their weekend cleaning up a disastrous resin spill.
All right, Section 3, the step-by-step regeneration process.
This is the core execution you can literally take directly to your next shift. We start with Step 0, which is prep. Never ever start without your chemical-resistant gloves, boots, and goggles. Then, you've got to physically verify your brine tank is at least 1/3 full of high-quality salt. Remember, the floors around the brine tank are going to be wet and extremely slippery, so those non-slip boots are essential. Make sure the edgeter isn't clogged, check for leaks, verify your valve positions, and once everything is confirmed, go ahead and set your control valve to regen mode.
Here is your chronological roadmap for the actual mechanical phases. We are going to execute exactly 6 steps to bring that bed back to perfect operating condition. Every single one of these phases on the LED sequence is critical. We'll hit backwash, brine draw, displacement rinse, fast rinse, refill, and finally return to service. Let's break them down.
Step 1 is the backwash. We're forcing water up from the underdrain at 5 to 10 gallons per minute per square foot. This is an upflow process designed to fluff the resin and expand the bed by 30 to 50% to purge out trapped mud and broken beads. You're going to run this for about 10 to 15 minutes. If you look through the sight glass, it'll start out murky brown and gradually clear up. If it's still dirty after 15 minutes, you've got a much bigger issue with your feed water.
Step 2. Brine draw and slow rinse. This requires a 30 to 60 minute contact time, and we go slow for a reason. The adductor turns on, and that 10% diluted brine flows into the column at an incredibly slow rate, about 0.5 to 1 GPM per cubic foot of resin.
We need the mass action of that overwhelming sodium concentration to thoroughly chemically evict those hardness ions right off the beads and out to the drain.
Once the brine is drawn down, we hit step 3, the displacement rinse. Now, whatever you do, do not rush this part. Use clean water to gently push that lingering brine out over 20 to 30 minutes without scrambling the newly settled resin bed. If you skip this or rush it, you trap high concentrations of salt right in your bed, and your product water quality is going to instantly tank.
Then we hit step 4, the fast rinse. This is a high-speed downflow flush operating at a fast 1.5 to 2 GPM per square foot for 10 to 20 minutes. The goal here is to completely wash away any leftover sodium and hardness. And listen closely, you do not stop this downflow flush until your test kit proves that your hardness is firmly back under your 1 milligram per liter threshold. You have to continuously sample the output water and run those titration tests.
Finally, steps 5 and 6. Ensure your tank automatically refills so the water level is 10 to 15 centimeters above the salt, and return the system to service. That refill is absolutely vital so you have a fully saturated batch of brine ready for the next shift. Once flows and pressures are normal, put it back into service. And brothers, you have got to log your salt usage, water usage, and times. That log is literally the only way to track the degradation of your resin over time.
Section 4, Safety and Key Takeaways.
To wrap up this explainer, let's review the critical safety protocols that dictate your long-term success on the floor. We cannot cut corners here. Keep your floors dry to prevent slipping. Watch out for high-pressure leaks during that fast rinse, and always route your waste to the neutralizer as required by environmental specs. Saturated brine is mildly corrosive to both metal and your skin, so keep your PPE on whenever you're inspecting the tank.
Now for the ultimate operating rules. Cheap salt literally kills your resin. Skipping the backwash causes severe channeling, and failing to log your data blinds you to your system's real operational costs. Always use high-quality, low-impurity water softener salt. Never let the tank drop below 1/3 full, and don't perform your backwash carelessly.
I really can't stress this enough, and it is a hard, non-negotiable rule. Testing hardness after regeneration is mandatory, not optional. It is the absolute final seal of approval, and the only true indicator that your entire shift's process actually worked the way it was supposed to.
So I want you to think about this as you finish up today. Are your daily operation logs actually optimized to predict your next resin failure before it happens? Are you just scribbling numbers down on a clipboard, or are you actively tracking the SCADA trending graphs to completely master your UPW system? When you document everything thoroughly, you stop reacting to failures and you start predicting them. Take these standard operating procedures back to your plant, follow them step by step, and keep those systems running pure. Thanks for joining me on this explainer, brothers. Catch you next time.